Okay, ladies and gentlemen, today in class and for the next few days, we're going to be solving a lot of different forms of quadratics, okay? We learned the quadratic formula a little bit, but now you're going to see there's different varieties of quadratics. So let's get started. For example, if you look at this one here, notice we have a k squared term and everything here is kind of out of order, right? The key thing to remember, guys, we always want this over here to equal 0. So I'm going to rearrange it and make sure that that 26 right there is gone. Okay? So here we go. First of all, how about if we go ahead and minus 26 both sides? Now we have 0 equal, and over here I have negative 16. How about if I put that there and take the 121k squared and moved it to the front? Now that we have equal to 0, notice all I have is a k squared term and a constant term. There is no k in the middle there, is there? There is no k. So I could use quadratic formula, but you know what? Because there's no k, I'm going to solve it directly. Again, when only there's a x squared or squared variable and no middle variable, in this case no k, you can solve it directly. So it's kind of backwards, but what we're actually going to do now, is go ahead and add 16 to both sides. Okay? What does that do? Well, that leaves us here 121k squared equal to 16, right? Now I can divide by 121, you see. And with the 121 divided by 121 equal to 1, I now have k squared equal to 16 over 121. Now what can I do with this right here is hopefully we understand to solve for k, can't we just simply do a square root? Look at the blue here. See how I'm square rooting both sides? Because the square root of k squared, you see, is k. So I'm going to square root both sides. I'm going to get k equal to, again, this right here is now k if I square root the k squared. And I got the square root of 16 over 121. And hopefully you realize that I can do the square root of 16 and get 4, and do the square root of 121 and get 11. So k is 4 over 11, and the only thing else I have to remember though, guys, and this is kind of weird, but I can have a positive or negative 4 over 11, so we're going to have to discuss that part in class, okay? But hopefully you get the gist of how you can solve it directly. Now, pause the video if you need to. I'm going to go on to another problem. Okay? So here we go. Notice this one, I already have it factored here, don't I? So this time we are going to use what we call the zero property. And I basically already shown this to you before, but now you know the official name. It's called the zero property. So you simply take m minus 2 and say, when is m minus 2 equal to 0? And hopefully you agree that's when m is 2, correct? And then you take this and say, hey, when is 2m minus 3 equal to 0? Well, I can solve for m, can't I? I'm going to go ahead and add 3 to both sides. 2m equals 3. And then when I divide by 2, I know m is 3 halves, or 1.5. Sorry, it's a little messy there. So I know m equals 2, or 1.5. Okay, so pause the video again if you need to, before we move on to one more problem. Okay, so one more problem. So look at this one, guys. Notice we've done one similar to this. Notice this is a typical quadratic. It's not equal to 0 though. So does everybody agree the first thing we're going to do is minus 6 both sides? And when we do that, we'll end up with 5n squared minus 21n, 10 minus 6 is 4, equal to 0. Now guys, the thing I want to remind you is we actually have two choices. We could try to factor this, or we could use the quadratic formula. Okay? And so first thing I'm going to do is actually factor. I'll use light blue here. And hopefully you agree 5n times n is 5n squared. 4 times 1 is 4. And notice, if you look at our inner and outer loops here, 1n and over here 20n, I can make minus 21n by making these both negative, right? And so, knowing that that equals 0, I can solve this one like the previous problem. Let's start with this piece right here. 5n minus 1 equals 0. When does it equal 0, in other words? Well, that's when 5n equals 1 and n equals 1/5, right? Because what I'm going to do is divide both sides by 5. So n is 1/5. What else? If I look right here, when is n minus 4 equal to 0? Well, that's when n equals 4 again, right? So notice n will either be 1/5 or 4. Okay? Now, just to reinforce the idea, could we have done this with quadratic formula? And the answer is yes. So let's go ahead and add a new page here. Hopefully you agree that A would be 5, B would be negative 21, and C would be 4. Let's double check that. 5, negative 21, and 4. Looks good. So, could I not do the negative of b plus or minus square root b squared minus 4, that's a squared right there, minus 4 times a times c all over 2 times a. Okay, what's next? I know negative of negative 21 is 21 plus or minus the square root. And 2 times 5 gives me 10 in the denominator. So now I'm going to do everything in the radical with my calculator, correct? And when I do everything in green there, guys, I get 361. Make sure you do get 361 in the radical. Now, what is the square root of 361? Well, that's 19. So notice what I have finally is 21 plus 19 divided by 10, and 21 minus 19 divided by 10. Again, I did the plus and minus there, right? And let's see, 21 plus 19 is 40 over 10. And what do you know? I get 4, don't I? And 21 minus 19 is 2 over 10. And if I reduce that by dividing by 2, I get 1/5. And notice I have exactly the same solution as I have right here. So the one thing I hope you learn from this video, guys, is you can always use quadratic formula and you will get the same result. As you can see, here I did the quadratic formula. I got the same result here, didn't I? As if I factored. And with factoring, I can use zero property, as I already showed you. And the key thing to remember, though, guys, you can't always factor, though. You can't always factor, but when you can, you should, because I hope you agree this went a little bit faster than the quadratic formula. Okay, so next time, well, until next time, guys, I'll see you later. Bye.